Section 5.5 has to do with the double angle formulas. And again, we're looking at our reference sheet with all the identities and formulas. And you have three choices for cosine 2a, depending on what you're given. You have sine 2a and tan 2a. So let's just look at one question here. Solve for cosine theta and sine theta if you are given that cosine 2 theta equals 3/5 and theta is in quadrant 1. So you want to choose a formula that fits, that might be the easiest. So all we know is cosine 2 theta, and we could choose various ones, but if we choose the one 2 cosine squared minus 1, there we go. So let's try that. We plug in the 3/5 because we were told that's what cosine 2 theta is, and we go there. Now we're going to solve for theta, or cosine theta. So we're going to add 1, and 3/5 plus 1 is like 3/5 plus 5/5. And we have 2 cosine squared theta equals 8/5. Then we divide by 2, which is like multiplying by a half. And so when you do that, you're multiplying 2 times this 5. So we have 8 over 10 equals cosine squared theta. Reduce that, that's 4/5. Take the square root of both sides. So cosine theta is plus or minus the square root of 4 over 5. So that's like 2 over the square root of 5, because the square root of 4, we can take the square root. Then we need to rationalize that. So we have square root of 5 over square root of 5 there. So we have 2 square roots of 5 over 5. That's cosine theta. Then we can use our sine squared plus cosine squared theta equals 1 and plug in what we just solved for. And so we've got sine squared theta plus this squared equals 1. When you square this, you're multiplying it by itself. So you have 2 times 2 is 4. Square root of 5 times square root of 5 is 5. 5 times 5 is 25. So we end up with 20 over 25. That reduces to 4 over 5. So we're here. So subtract the 4/5. So when you have 1 minus 4/5, you're left with 1/5. Take the square root of both sides, and you get 1 over the square root of 5. By the time you rationalize that, you're here. You have square root of 5 over 5. So that's using a double angle formula, just if you're given it and you're solving for the others. In our other problem set, we'll do it a little bit the other way. So let's go look at those. All right. If I can get this down, hold on. All right, I think I've got that fixed. So you're given that cosine theta is equal to 40 over 41 and that sine theta is positive. Determine the values for sine and cosine functions for 2 theta. All right, so sine 2 theta is 2 sine theta cosine theta. Well, we don't know sine theta yet, so let's go back and try to solve for sine theta. Now, how did I come up with this? Well, remember that if we know sine squared plus cosine squared equals 1, then sine squared is 1 minus cosine squared, and then sine is 1 minus the square root of that, 1 minus cosine squared. Now, we know that sine is positive, so we don't have to put a plus or minus here. We have square root of 1 minus cosine squared theta. Let's put in our 40 over 41. When we square that, we get 1 minus 1600 over 1681. Well, we need to make this all one fraction, so we need to put this as 1681 over 1681. So we got 1681 minus 1600 over 1681. That becomes 81 over 1681. If I take the square root of both of those, I get 9 over 41. That's what sine theta is. Now to find sine 2 theta, it's 2 times 9 over 41 times 40 over 41. We were given this one. We solved for this one. We multiply across the top, so 2 times 9 times 40 gives us 720. And across the bottom, we get 1681. Cosine 2 theta, we can use cosine squared theta minus sine squared theta. So we have 1600 over 1681 minus 81 over 1681. And we get 1519 over 1681. So we're just using our formulas. All right. 2 theta, find 2 theta given that sine theta is equal to negative square root of 2 over 5 and cosine is positive. So where is sine negative and cosine positive? Well, sine is positive here and here. Sine is negative here and here. Cosine's positive here and here. Where those overlap is quadrant 4. So let's draw our triangle from quadrant 4 out from the origin up to the x-axis. Here's my negative square root of 2. Here's my 5 because sine theta is opposite over a hypotenuse. I need to solve for this value. So it's that Pythagorean theorem. Negative square root of 2 squared plus x squared is 5 squared. So I've got 2 plus x squared is 25. Subtract the 2. So I get x is square root of 23. Now I have all three. So cosine theta is square root of 23 over 5. Once I have this and I'm given this, I can do cosine 2 theta. Plug in the values, square them, and I get 23 over 25 minus 2 over 25, which is 21 over 25. Then I could do sine 2 theta, 2 times that value times that value. You get 2 times negative square root of 46 over 25, and that will be your final answer. Number 3. Okay, so we were given that cosine 2 theta is a value. Remember, that's like the one we did in the lecture notes. So I plugged that 40 over 41 equal to this formula. Remember, we solved for cosine theta. So you come do all that algebra and come down to here. So cosine theta is plus or minus the square root of 81 over 82. On the top, we can get 9 over the square root of 82. Rationalize it, you get negative 9 square roots of 82 over 82. So we were supposed to find cosine. Then we need to find sine. So we're going to plug this in for cosine here and solve for sine. So we square that. We get 81 times 82 over 82 squared. And that becomes 81 over 82. Subtract that over here. So sine squared theta equals 1 minus that. We make this 1 82 over 82. So we end up with sine squared theta is 1 over 82. Take the square root of that. You get 1 over the square root of 82. When you rationalize it, you get this. Number 4, use a double angle identity to find the exact value of the expression. So you're given cosine squared this minus sine squared that. That is like cosine 2 theta equals cosine squared theta minus sine squared theta. So cosine 2 theta is equal to this. So that means there's your theta. The 135 is your theta. So cosine of 2 times 135 is equal to cosine of 270. That's a value we know, and the cosine of 270 is 0. All right, number 5 is the same idea. You're given 1 minus 2 sine squared 15. So cosine 2 theta can be 1 minus 2 sine squared theta. Plug in the 15, and that is 2 times the 15, and you get, because your theta is 15, so cosine of 2 times 15 is cosine of 30, and that is square root of 3 over 2. So just a few of those to get you going on the double angle formulas.